Okay, now that you've done this exercise and we're getting a little bit of practice with percentages, you should be in a place to be able to really understand example 2 and see how all of this is going to tie together and see how we can approach new kinds of problems with using this concept. So a person invests $500 in year t equals 0 and then earns 10% interest each year. Let's fill in the table and then find a formula for the balance b of t after t years. So filling in the table first, at year 0, that's when their balance is what they invested, which is $500. And then after that, they're earning 10% interest. So that means this should be increasing by 10% in year 1. So let's look at how do we increase something by 10%. It's going to be kind of like this example G. We're going to take the original 500 plus 10% of 500. And 10% of 500 as a decimal would be 0.10. After you move the decimal place over twice. And so that's going to be 500 plus 10% of 500 is 50, and that gives you 550. Okay, so this is 550. Now, this is going to be a little awkward to do that every time. If I wanted to find out what is the balance after 2 years, am I going to do 550 plus 10% of 550? And then for year 3, am I going to do that amount plus 10% of that? There's a better way to do it. So let's try to connect what we did in the previous exercise here. What if instead of writing it as the original amount plus the percentage, what if we write it out this way? So instead of doing it like this, what if we write this as 500 times 1 plus 0.10? Because if you distribute this, the 500 times 1 is this 500. The 500 times 0.10 is this part. And that's the same thing as doing 500 times 1.10. In other words, this is saying that instead of taking 500 plus the 10%, what if we just say 110% of 500? That's the same thing as 500 plus 10% of 500. And that's the way we did it with example or exercise 1A here. So that works there. So for this one, instead of doing 550 plus 10% of 550, what if I just say I'm going to do 550 times 1.10, 110% of 550. That's going to come out to be, I might need a calculator for that. We're going to get 605. So now that's how we can get that. But there's another way to see this too, is the 550 we have here. We know that 550 is 500 times 1.10. So what if we think of this another way as 500 times 1.10 and then times this other 1.10. So the 500 times 1.10, that's the amount in year 1 here. And then if you multiply that by another 1.10, take another 110% of that, you'll get the new amount, 605. And that is the same thing as 500 times 1.10 squared. So the idea is every time you go up in the table, go up by 1 year, we're multiplying by another 1.10, which is 110%. So to calculate how much there is at year 3, we can say, I could either take 605 times another 1.10, or to get b of 3, I could say I'm going to take the original amount, 500, times 1.10 is the year amount after year 1, times another 1.10, that's the amount after year 2, times another 1.10 is the third increase of 10%. And that's the same thing as 500 times 1.10 to the power 3, which is 500 times 1.10 to the power 3, 665.5. So you could also get that. Let's just check. If you do 605 and you do 605 plus 10% of 605, that should also be the result of taking $605 and increasing it by 10%. And it comes out to the same thing. So the formula in general that we're getting here is that b of t is going to be the starting amount, 500, and then because every time t increases by 1, you multiply by 1.10 again, we can write that as 1.10 times 1.10 times 1.10 t times, or just 1.10 to the power t. All right, and that's kind of the main idea of this section. So let's try to tie this all together, make it a little bit more abstract. So like, what if you have other letters instead of 500, instead of 1.10, and other percentages? How does this work in general? So we have that if a quantity q equals f of t is changing by a constant percentage, and r is the percent rate of change written as a decimal. So in this example here, this is changing by 10%. So that 10% interest, we would say that r equals 0.10, writing that as a decimal. And yeah, that's also called the growth rate. This is a 10% growth rate. Then the formula for the function is this. We could write it as f of t equals a times b to the t, but the b is going to be the same thing as 1 plus r. And just like in the last section, f of 0 is going to be a. That's what 6.1 was all about. So that a is called the initial value. And just like in the last section, every time t increases by 1, the result of the function gets multiplied by b, which is why b is called the growth factor. In this previous example, the growth factor is 1.10. Now, if r is positive, then let's think, b equals 1 plus r. If you do 1 plus a positive number, how does that compare to 1? Is it greater than 1 or less than 1? Well, 1 plus a positive number is greater than 1. And when b is greater than 1, let's look at what that tells you about the function. Is it increasing or decreasing? important thing to know here is this is from the 6.1 notes. We had an increasing function when we had something for b like the number 3, or when b was something like 2, but when the b was less than 1, like 0.5 or 1/3, it makes it a decreasing function. So when b is greater than 1, the function is increasing. If r is negative, then b equals 1 plus a negative number is less than 1. And when b is less than 1, that was like the examples for exercise 4, part C and D here, that b equals 0.5 or b equals 1/3 gave you a decreasing function. All right, so again, the stuff in a box is stuff you're gonna need to know. And if you're somebody who's good at memorizing stuff, if that's the way you like to study, that's okay. That's one way to learn it. Another way is to try to make connections using logic between all the different ways of looking at it and constantly thinking about stuff that way. And that's the way I like to do things, is try to do each problem 1 or 2 or 3 different ways maybe, to try to make connections between the different approaches. Just like you could see that A, D, and G were kind of the same thing. Try to do a problem all 3 of those different ways to make the connection as you practice. And the more you practice that logic, the better off you'll be. So anyways, let's look at a few examples here. We have a quantity increases or decreases by the given percentages. So does that mean that 3% is the B or 3% is the R here? Well, if it says that it changes by a percentage and that R is the percent rate of change, we have a percent rate of change here. So this is R, but we want to write that R as a decimal. What it actually means is a number, which is 0.03. And with that, let's see. So yeah, that's the R. So we want to know the growth factor. The growth factor is the B, the thing that you actually multiply by here. And the B and 1 plus R are always going to be the same thing. So the B is always 1 plus R. And in this case, that's going to be 1 plus 0.03, which is 1.03. So in other words, if you want to increase something by 3%, then you multiply it by 1.03, which is the same thing as 103% of what you had before. All right, what if you have 0.05%? Well, just like here, you took the decimal place, it was 3.0 here, and you move it over 2 times. It becomes 0.03. Now the decimal place is here, and we need to move it over 2 spots. So this, as a percentage, is going to be 0.0005. So 0.05% is a very small number. And we're going to use this fact that B is always equal to 1 plus R. So if you want to increase something by 0.05%, you're going to multiply it by 1 plus 0.0005, which is the same thing as 1.0005. And by the way, as a percentage, this would mean 100.05%. So to increase something by 0.05%, you'd multiply it by 100.05%. All right, so if this is negative here, it means it decreases. So if it's decreasing, we have a negative r. The r here is negative 0.26 after you move that decimal place over 2 times. So the b equals 1 plus r is going to be 1 plus negative 0.26, or 1 minus 0.26, which comes out to be 0.74, also known as 74%. So what this means in a real life situation is if you want to decrease something by 26%, that's the same as multiplying it by 74%. Let's look at a couple more here. We have the following growth factors. By what percentage does it increase or decrease? So if you multiply by 1.07, this is your b here. That b is always equal to 1 plus r. And what we want to know when it says what percent does it increase or decrease, that means the question is asking for r. That's what r represents here, the percent rate of change. So let's see. We have 1, and remember, b is always equal to 1 plus r. That's a super important idea in this section. So if you do 1.07, that's equal to 1 plus r. How do you get r? You could just subtract 1 from both sides, and you get 0.07, which is 7%. I guess if it's asking for by what percent, we would say this is an increase of 7%. So in other words, multiplying something by 1.07 is the same thing as increasing it by 7%. And if you're confused about why those two things are the same thing, I think it's a really good idea to go back to exercise 1 and see how that all worked out here. How A, D, and E were all the same thing, and why B, E, and H were all the same thing, and why these were all the same thing. Okay, so now with 0.90, we're saying that's equal to B. So if you want to get R, then we're saying 0.90 should be 1 plus R. Subtract 1 from both sides. And 0.9 minus 1 is going to end up being negative 0.10. So that as a percent is negative 10%. Now, if this is your growth factor, if you multiply something by 0.90, it's going to get a little smaller, because 0.90 is less than 1. And the amount that it's getting smaller by is going to be 10% of what it was before. So multiplying something by 0.9 leaves you with 90% of what you had before. It's the same as decreasing it by 10%. Okay, this one's getting a little bit weird. 2.24 is RB, also known as 1 plus R. So to make that equation, we have 2.24 is 1 plus R. What is the R? Just subtract 1 from both sides. You get 1.24. As a percentage, that is 124%. And because this is greater than 0, it's an increase. Multiplying something by 2.24 makes it bigger. Okay, so let's look at this. If we want to state the starting value of A and the growth factor B and the percent growth rate R for each of these. So this is trying to sort of bring this together. We have an exponential function. We can think of an exponential function as a times b to the t, or you can think of it as a times 1 plus r to the t. And this section is all about how the relationship between the b and the 1 plus r. So right now this looks like b to the t, like it's not written as addition here. So the b would be 1.004. The a is whatever you have in front. And the r is however much over 1 this is. So you could write this as 350 times 1 plus something to the t. And whatever the something is that's what the r is. So in this case, this would be 0.004. And that's going to be the r. And if you want to write that as a percentage, you're just going to move the decimal back the other way. It's 0.4%. So that's the answer to that. Okay, here again, the a is the simplest part. That's whatever's multiplied in the front. The b, this is written as the one. This is just a number to the power t, so that number is the b. And in this case, this b is 0.25. Now, how can you get this to be written as 1 plus something to the power t? Well, whatever this r is, it's going to be 0.25 minus 1, which is negative 0.75. So 1 plus negative 0.75 is the same as 0.25. So yeah, that means the r here is negative 0.75. So it's a decrease of 75% every time t goes up by 1. How about this one? This one's a little bit weirder. So the process that I was doing here to get the r, it's basically the same thing as what I was doing here. Like I'm taking the b and I'm getting whatever that b is minus 1 to be the r. So here you have b is 1.004. That minus 1 is the r that goes in there to make this work. Here, the 0.25 minus 1 is that. So in this case, we still have a equals 100, and the b is 0.9984. And we could go through the same process as before if it's not obvious what the number r should be. If you're having trouble filling in this blank, you can always just say 0.9984 is equal to 1 plus r, and then just do minus 1 from that. And if you need a calculator for that, you're not alone. That's going to be negative 0.0016. So yeah, you could write this as 100 times 1 minus 0.0016 to the power t. And you could also write this as a percentage. You could write this as a negative 0.16% if you move the decimal place over 2 times. Also the answers for A and B here. All right, so that's how this works. Exercise 2 that you have coming up is very similar to example 3. So if you understood example 3, try to do the same thing I was doing there for exercise 2. And exercise 3 is kind of the same idea as this example 5 here. So you can try to do that process, but it's important to try to understand what you're doing at the same time. So in the next video, I'll show you some solutions to these exercises. Good luck with them.